Hey guys, today we are going to talk about two new measures that you can find in a circle, and it's going to be arc length and sector area. So we're going to start with arc length. So the arc length is basically just going to be a fraction of the circumference of a circle. So we're going to talk about what that means. So there's going to be major arcs and minor arcs. And so basically what that means is a minor arc is going to be, it's like less than half the circle. So that means it's going to be less than 180 degrees. And a major arc is going to be more than half the circle, so it's going to be greater than 180 degrees. And then for a minor arc, it's only going to be labeled with two letters. So like if you have minor arc AB, then it's just going to be the outside distance around the circle from point A to point B. So labeled with two letters. And then to indicate that you're going like the long way around the circle for a major arc, it's going to be labeled with three letters. So then if you look at this example that we have down here, then the first thing it says is arc AB. So arc AB, since it's labeled with two letters, is just going to be a minor arc. And that's going to be the distance from point A to point B on the circle. And then let's change our color here. So then we have AZB as our other arc, and AZB labeled with three letters is going to be a major arc. And so for that major arc, the Z that's down here at the bottom is what's helping indicate that we're going this long way around the circle from A to B. We need to cross through Z. So that would be a major arc. And then angle AOB, so that's going to be this angle right here. That's going to be called a central angle, and that's because point O is just at the center of the circle. And so whenever you're doing arc length and sector area, you're going to be needing to use a central angle. And then, so an arc's measure, so like for arc AB, it's going to be the same as the central angle that intercepts it. So say that angle O, so like AOB, say that that angle is 72 degrees. I'm just going to throw a random number up here. Say that that's 72 degrees. Then the measure of arc AOB would also be 72 degrees if you were looking at it in degrees. So just know that the measure of the angle is going to be equal to the measure of the arc. And then for the arc length, what I said earlier, the arc length is going to be a fraction of the circumference of the circle. And so for the measure of arc AB, as in like the arc length, the way that you're going to find that is you're going to use, to find like the fraction that it is, you would use the degree of the central angle. So I'm just going to put a little angle symbol here over 360. So that'll give you like the fraction of the circle that you're using. And then times, that's supposed to be a multiplication dot, times the circumference, which is 2 pi times the radius. So then again, I'm just going to throw a random number up here. Say that the radius of the circle that it gives you is 6. Then if you wanted to find the actual arc length, then you would be using the degree of the central angle, which is 72, divided by 360, and then times 2 times pi times the radius, which is 6. And then you would type all of that into your calculator to find the answer. So I'm going to use the alpha y equals to get the fraction in there. And it was 72 over 360. And then it was times 2 times pi and times r, which is our radius of 6. And that gives me 7.54. is the length of this arc from A to B. So 7.54 would be that length. And then the other thing that you would be talking about with these is sector area. And so a sector, we just looked at arcs, but a sector is going to be like a wedge of the circle. So let me change the color, or actually let me just highlight what I want here. So for our sector, with it being a wedge of the circle, you actually need the area on the inside. So like this whole little like piece of pie or slice of pizza or whatever you want to look at it as, then you're finding the area of that shaded portion that I just did there. And so I said a sector's measure is going to be a fraction of the area this time of the circle. So just like with arc length, you're going to be using a fraction of the circle. So to get the fraction of the circle, it would be that central angle measure again, divided by 360. And then times, this time it's the area instead of the circumference. So it's going to be pi r squared. So if I did that with our example that we have here, then it would be 72 divided by 360 times pi times our radius of 6 squared. And so I'm going to go ahead and type that in and see what our sector area would be. So again, I'm going to use alpha y equals just to get my fraction bar in. And I had 72 divided by 360. And then I need times pi and times my radius, which is 6 squared. And you end up getting 22.62 on that one. So that would be representing a sector area, and then our 7.54 up here was our arc length. And then I'm just going to show a couple more examples of this, and that'll be it for sector area and arc length. All right, so I want to find both sector area and arc length for both of these two little circles. So I'm going to do arc length on this left-hand circle first. So for arc length, remember it's the degree or the angle, the central angle, over 360 times 2 pi r. And then in this one, it gives us that our central angle, or it also is the measure of the arc there, is going to be 36 degrees. So 36 over 360 times 2 times pi times the radius, which is 6. So for our arc length there, I do want to show you how to do one other thing. If a question ever asks you to put your answer in terms of pi, then you're going to type it into the calculator a little bit different because you want to have that pi still in your answer. So what you're going to do is actually type in literally everything else, but we're not going to type the pi in. And I'll show you what I mean. So, and if I move it over here, you can see it a little better. So, we had 36 over 360. And then I need that times 2, and then it's times pi, but I'm not going to type that part, and I'm just going to do times 6. And I end up getting 6 over 5. And so what that means is that all of this equals 6 over 5 times pi, because we didn't multiply the pi in there. And so the way that would be written is like 6 pi over 5. And then that would be your answer in terms of pi. Or if you actually want to work it out and get the numerical answer, then I'm just going to take my 6 over 5 and multiply by pi. And I'll get 3.78. So this would be my answer, or if it asked for it in terms of pi, then you would just leave it as 6 pi over 5. And then I want to do the sector area for this one as well. And so for sector area, I need the angle measure over 360. for my fraction of the circle, and then times pi r squared, because that would be times the area of a circle. So my angle measure is 36 over 360 times pi, and then times the radius is 6 squared. So I'm going to do the same thing. I'm not going to type the pi in here. I'm just going to do my 36 over 360, and then I'm going to do that times 6 squared. And I end up getting 18 over 5. So if I wanted this in terms of pi, then it would just be 18 pi over 5. But then if I actually solve that out, I'm just going to multiply this by pi. And I would get 11.31 as my answer for sector area. And then I'm actually going to copy this one over onto the next page so we have more room. Okay, so just like on the last one, I'm going to go ahead and start with my arc length. So for arc length, I need the angle over 360 times 2 pi r, because it's times the circumference. So for my angle in this one, and I'm doing the shaded part, so the arc I'm looking for is this one here. And it doesn't actually give me my angle, but it shows an angle that's supplementary to it, which just means like they add up on a line. And then supplementary angles are going to add to 180. So to find this angle, I can just do the 180, which would be that whole like straight angle right there, minus the 72 that's not included in the shaded part, and then that's going to give me 108. So my angle that I'm going to want to be using is 108 right there. So for my arc length, I would have 108 over 360 times 2 pi times the radius. And then the radius is a little bit tricky on this one too, because it gives you the diameter. So remember, the radius is only going to want to go halfway across the circle, and so we need half of that diameter. So it would be the 10 divided by 2, and it's actually going to give you 5. So my radius that I'm going to use is 5. And on this one, sorry, my dog was making a little bit of noise there. On this one, I'm not going to worry about trying to put it in terms of pi. I just want to type it all in so that you guys can see it, just like for the numerical answer. So I'm going to do alpha y equals and get 108 divided by 360. And then I need times 2 times pi times my radius of 5. And I end up getting 9.42 for my arc length. And so then I'm going to switch the colors here so that we can tell the difference. So then I'm going to do the sector area. So for sector area, I need the angle again over 360 times pi r squared. So the angle we said was 108 over 360 times pi times the radius of 5 squared. And then I'm going to type all of that into my calculator. So I need, I pressed the wrong button, I'm sorry. I need 108 over 360 times pi, and then times the radius squared, which is 5 squared. And I end up getting 23.56 for my sector area. So that is pretty much the concept of these two. So the most important thing is just to remember those two formulas. So make sure that you get those written down and are able to use them, and you should be good to go.